Okay. All right, let's do it. This is day 2 of 4-1. You are going to be doing this today. You are going to look at the unit, kind of the unit circle that we were looking at yesterday. This says the relationship between rotations. So you're going to be looking at rotations around a circle. So I'll just draw you a quick circle. You're going to look at the distance you travel around the circle. So if you're here, okay, if that's you here, and you travel this far, I want the distance. Okay, what's the distance between this point and this point? Okay, that's called something. I'll tell you in a second. And then the other thing you're going to look for is this, velocity. Velocity is simply going to be how fast did you travel. There's two ways to explain velocity. One is the way you normally talk, 2 miles per hour, 20 miles per hour. There's another way to say it. It's called angular velocity, which means I'm traveling 2 radians per minute, 3 radians per hour. That's another way to say it, okay? And that's what you're doing today, okay? Next slide, here we go. I noticed when I looked at your notes, you can't even read those letters. So you might want to start by going like this. From here to here is what? Radius. Put an R there and you can hardly see it. From here to here, this is called the central angle. It's called theta. Now, I did notice period 5, they were asking me, what's the central angle? Because the book talks about the central angle. Well, there's the central angle. It's right there at the center of the circle, right there to right here. This angle is called the central angle. It's called theta. What's that letter?
S.
S. And this is the distance you traveled around the circle. We call it S. S is also known as the length of the arc. So we're going to call this what? Arc length, period. That's it. Okay? All right. Now, let me read this to you. It says this. Radian measure allows us to connect angle rotation to the lengths of the arcs of a circle and the movement around the circle. Now, do you remember this from yesterday? Yesterday I talked about if the radius happens to be 3 inches long, okay? And I tell you, from here to here is 3 inches, and I tell you the central angle is 1. John, I'd be listening, since you weren't here yesterday. Guys, what does the 1 mean? One what?
The degree of the...
Is it 1 degree? I don't have a degree symbol there. So without a degree symbol, you know what it is? It's 1 radian. Now what does 1 radian mean? If this is 1 radian, it means take 1 radius and do what? Wrap it around the circle. Boom, right there. How far did I travel from here to here?
3 inches.
3 inches. How did you know it was 3 inches? Because your radius is 3 inches. You wrap it around the circle. There's 3 inches. So the answer is arc length, 3 inches. Your hands up, John.
Last year, I think I did something and I found out that 1 radian is approximately like 15.6% of the circle.
Okay.
If I remember correctly.
Okay.
I asked for your help on that.
And I asked you last year to come in after school. Let's talk. Let's not change the whole idea. John, I know what you're doing. You're doing some calculations. You want to know what percent of the circle it is. Doesn't matter. I'm just trying to get across to everybody what 1 radian is. 1 radian is 1 radius wrapped around the circle. Since this is 3, this is 3, right? But what if I change it on you? What if I say 2? Okay, look, if that's 1 radian, that would probably be 2 radians, correct? How far is S, arc length? How far did I travel?
6 inches.
How'd you know it was 6? It's 2, because there's 2 radius wrapped around the circle. And you knew this was 3, and another 3, so you know the answer is 6. What's a quick way to get the answer? What's a quick way to get the answer for S? R times what? R times theta, and theta is 2 radians, so yeah, you're right. Basically, that's it, isn't it? If I had Whoops, sorry. If I had a radius of 3, and I had how many radians for my central angle? 2. The answer's got to be 6 inches, correct? But what if I make it harder on you? Because I made that super easy, didn't I? What if I told you this? I got to erase some of this. It's getting really messy. What if I tell you the central angle? I'm going to get rid of that word, central angle. All this. What if I tell you the central angle from here to here? Okay. How far is it from here to here? If I tell you the central angle right there happens to be 7 pi over 6. Now how do you do it? You don't have to tell me the answer, just tell me how to do it.
3 times the radius.
Okay, you take the radius, 3, times the central angle, theta, measured in radians. Isn't this radians? Okay, you just replace the 2 with what? 7 pi over 6. And you have to understand, that is a number. It's not 2, it's not 3, it's not 4. It's really what? That's like 7 times 3.14, that's like 21, 22, divided by 6. It's probably right around 3.5, 4. But really, it's just a number, and whatever that number is, take that radius times that number. And your answer is what? Who can do that in their head? 21 what?
Pi over 6.
21 pi over 6. Sorry, that doesn't look good. Try that again. 21 pi over 6. But you can reduce that answer to what? 7 thirds? 3 goes in there 2 times, right? 7 over 2. My fault. Okay, 7 halves pi is the answer. Now, how far did you travel? Well, you can say 7 halves pi inches. You can say that, or you can convert it over to a decimal. That makes more sense. So what is 7 times pi divided by 2? 10.999. So you have traveled how far around the circle? Inches, sorry. Almost 11 inches. You okay? Did you see what happened? Now this green box is just telling you what you have already figured out, so it's not going to be a big surprise to you, but you should write this down. Today when you start your assignment, you need to understand this is huge. S equals R theta. S stands for what? What did the S even stand for? Arc, wasn't it the arc length? Okay. What did R stand for? Radius. Okay. What does theta have to be measured in? Radians. Okay, it says right here, where theta is measured in radians. So if they give you degrees in your book, they will, by the way, they're going to give you degrees. It's a trap. You're going to set your foot in the trap and you're stuck. Get out of that trap. Don't do degrees, do radians, okay? Convert it over to radians as soon as you see it. Okay? You good? Okay. Next slide. Do it. Do that problem. What is the length of the arc swept by the tip of the minute hand of the clock in 20 minutes if the radius of the hand is 12 centimeters? By the way, this is the minute hand. It's longer. This should probably be a little shorter. That's the hour hand, right? Okay. This is 12 centimeters, right? There you go. How far is the arc? I just did a problem like this with you. 3 of them. Start with the formula. you have it, showing. Isn't that what you're looking for? You're looking for S, the outside edge of the circle, the arc length. How far did the minute hand travel? From 12 to 4. Nobody has it yet? Yeah, what's the unit? How far did it travel? Yep, you got it. You got it. Yeah. I see what you did wrong. Remember this one. Go back to your previous slide. Your angle has to be in. Okay, here we go. You're looking for how far did the minute hand travel? That's the arc length from here to here. Okay, the radius is easy. What is it? 12 centimeters. Now, theta. Theta is the central angle. It's right here, guys. What's this angle? Right there. Well, I didn't give it to you, but you have to think circles. Circles, right? Well, if you made a complete circle, you travel how far in radius? In radius. 2 pi. So guys, if you do a complete circle, you have traveled 2 pi. Did you make it a complete circle? No, you only went a fraction of the way. What fraction did you travel?
30 thirds.
A what?
Third.
A third. How'd you know it was a third?
20 minutes is a third.
Oh, you did 20 minutes out of 60. So this is what Harry did. He said 20 minutes out of 60 minutes is 1/3. That's what he did. That's fine. You can do it that way. I did this. I said I looked at the numbers. I went 4 out of what? 12. I went 4/12, which is 1/3. That's how I did it. Harry he did it different. Okay. But what's 1/3 of a circle? How do you do this? What's the answer? 2 pi over what? 3. Guys, you traveled 2/3 pi radians. That's how far you went. The central angle is right here. That's it. So you put that here, 2/3 pi. You take it times 12 over 1. You get what? Probably easiest to cancel those two numbers out. 1 and 4. Answer? 8 pi what? Centimeters, right? Because this is 12 centimeters times, and this is just a number. It stands for radians, but it's just a number. Okay, so centimeters equals the arc length S. Now, quick, how far did the tip of the clock go? Give me a number, like something I can understand a little better. Roughly what? 25.13 centimeters. Okay, there you go. That's a little easier for me to understand. If you tell me I traveled this many centimeters, 8 pi, I'm like, oh, well, what is 8 pi? It's 25.13. Okay. Any questions? Okay, this is called what?
Trig.
No. This is called arc length. If you don't know what you're doing, then you're going to go to your assignment. You're not going to know what to do. You just found the arc length, the distance on the outside of the circle. Okay? That's all it is. Next, you're going to do what? Angular speed. Now, angular speed is how fast are you traveling around the circle? How fast? Well, you're going to say something like this. I'm traveling pi over 3 radians per minute, per second, per hour. That's what you're going to say. Here's the definition of angular speed. When an object is moved in a circular motion, r units from the center. Okay, so here's r units from the center right here. R units from the center. Here I go. I'm going to move. Here I go. Okay, of the rotation. The angular speed, what is angular speed called?
Omega.
Omega. Another Greek letter. Omega, here's what I do when I write it. I go like this. I put little like fins on the end. It's supposed to be italics, you know, so I can't do that, so I just go like this. This is omega. Omega is what speed? What? Angular speed. And when you say angular speed, you say 2 radians per second, like that. Well, how do you get that? Measured in radians per unit of time, and would be found with this formula. This many radians per unit of time. Give me some time.
20 seconds.
Okay, seconds. That's what I was looking for. Per second. It could be per minute. It could be per day. Whatever. It's time on the bottom. Okay? I'll give you a for instance. Ready? How far have I traveled in radians about here? Any guesses? 2? Okay. So you know what you just said? You said your central angle is 2 radians. Okay? You know what I'm going to tell you? Your time to get there, it took you this long. Half a second to get there. What's your angular speed?
Radians a second.
How much?
Radians a second.
Say that louder. 4 radians per second. How'd you get it?
But 2 divided by half.
Okay, he said, how many radians did I travel? 2 radians. How fast did I do it? Half a second. Your answer is going to be radians per second. Radians per second. How do you do this math? How do you do that? In your head. 2 on top? How do you divide by 1/2? Multiply by the reciprocal 2, so the answer is what? 4 radians per second. That's how fast you're traveling. Is that fast?
Depends on the size of the object.
Okay. Per second, 4 radians. Watch this. See, watch how fast it is. Ready? Here's 0 radians. I'm going to go 4 in a second. How far is 4 radians?
2 seconds.
What?
I know.
No. Remember, half a circle is pi. If half a circle is pi, that's 3.14. Where's 4? Right about here. Watch. Here's 1 second. 1001. Is that moving? That's moving, guys. That's pretty fast. What if I was only going 1 radian in a second? 1001. That's not moving very fast. 1001. 1001. That's moving fast. Okay. That's what speed is when we talk about angles. Okay. Hang on. We gotta try one. Okay. I don't know if you could see that or not. Could you? No. Okay. You might want to write that down. Try that. I'll try to make that a little larger. Okay. What is the angular speed of the minute hand of a clock? How fast is the minute hand moving?
60 seconds.
That's not angular speed. Angular speed is pi over 3 radians per second. You got to tell me how far is it going per second? Or in this one, I think we're going to do per minute. There's the minute hand. I just drew it for you. Omega. Omega. Angular speed. If you have it, raise your hand. I'll come to you. No. I'm just curious how you got that. You said, oh, 2 pi radian. Okay, you're saying it goes all the way around, but how long did it take to go all the way around? You said it took, you're saying it only takes 1 minute for the minute hand to go around. The minute hand takes a lot longer than 1 minute. Oh. Wait, I have it. What's that saying? That's it? Oh, pi? Yes, you have it. Okay. Okay, you guys ready? Here's the deal. It's a minute hand. It's a minute hand. Theta, how far did it travel? It doesn't matter what you say. It doesn't. But just most people will think circles. So let's pretend it goes all the way around. How far did it go? In radians. Divide. Okay? Time. How long did it take the minute hand to make a complete circle? 60 what? Minutes. So your answer is radians per minute. But I don't have 1 minute, I have 60. So do some division here. What's that divided by that? Well, you could reduce it and say what? 2 over 60 is really 1/30 times pi. Pi over 30. Radians per what? Minute. And there's your answer. That's how fast the minute hand is moving. But I did look at somebody's, I think it was Aaron. Aaron, you converted yours to a decimal. What was your decimal? 0.105. Radians per what? Per minute. Okay, which means 0.1 is 1/10 of the radius. So if the radius is this long, if that's the minute hand, 1/10 of that is what? About this much. So that means in 1 minute it's going to move how far? This much. That's about right, isn't it? It doesn't move very fast, okay? So this is the exact answer. This is the approximation, okay? Yes? It's kind of weird. Angular speed is weird. Okay, so what's coming next is what? Linear speed. That's what you guys are used to. That's like you're driving in your car and you're driving 25 miles an hour or 30 miles an hour or whatever. That's linear speed. Straight line, go. Okay, but hang on, listen to it. Linear speed is what letter? V. So this is linear speed. You might want to write this down. Okay? That's linear speed. Would be the rate at which an object is moving in linear units, arc length, s, per unit of time. Okay. That got weird on you, but just listen to what they've said. So linear units, arc length, they're talking like this. If you're here, if this is you, okay, and you walk in a circular pattern and you walk this far, okay, then you know the circle keeps going. But if all you walked was 200 yards, okay, and that's you walking 200 yards, and I tell you you did this in, 5 minutes, okay, look at what it says. It says linear speed is nothing more than s. What's s? What is s? Arc length. Good job. This is really just arc length. How far did you travel around the circle? Well, you went what? 200 yards. And this t down here is what? Time. So look at your numbers, guys. You went 200 yards in what? 5 minutes. Well, that'd be what?
4 yards.
200 divided by 5, right? Yards per minute. Answer? What's the answer? 40 what? 40 yards per minute. How's that? Is that fast?
No.
Not really. No. Some football players in the NFL run 40 yards in 4.5, 5 seconds. So you're not going very fast. That's pretty slow. But that's what it is. Linear speed is nothing more than what? Say it. Say it. Arc length divided by time. But wait a minute. What's arc length? Arc length is what? Radius times theta. This is what you did right off the bat. Do you remember that was your first problem? Okay. So this problem is nothing more than arc length divided by time. Okay? Try that problem. At what rate is a person standing on the equator moving? The radius of the Earth is approximately 2,960 miles. I found out period 4 and 5 didn't quite understand this. Some of them thought I meant how fast is this person actually moving like this. No. I'm talking, you stand on the equator, do you know the Earth is moving pretty fast? Okay, how fast are they moving? They're going to spin around the world. How fast are they going? Figure it out. That's linear speed, by the way. Go. Start with your formula. Trying to draw you some pictures, trying to give you formulas, get you started. Who has the answer? Mm-hmm.
Is that right?
Better hold on.
Well, we have a little thing called gravity. It's 9.81
Yeah, but
meters a second.
the equator might throw you. You might be out there in the ocean somewhere. Yeah, they got it. You want to just look at the formula. What does it say to do?
Is this accurate?
Yeah, it is. I mean, well, unless the radius is wrong. But I think that is the radius of Earth. You're moving. You got to go along the way.
No, I'm just thinking, what would it, how would you calculate the force of gravity?
Let's not, we have
I'm
other things to worry
I'm
about.
not thinking about your class, I'm thinking about my physics class.
All right, you guys ready? If you knew how far you traveled, that's arc length, and just divided by the time, it's that easy. Would you just look at the picture? That's you on the equator, spinning around the world. How fast you spinning? How fast you going? Well, everybody said, well, I don't know the angle. I don't care what the angle is. You make up what you want. I keep telling you guys, think circles. Why don't you say you traveled how far? All the way around the world. Okay, think of it that way. Here's you. You went that far. That's a complete circle around the world. That's how many radiuses? 2 pi. So if you want to think of arc length is really just what? R times theta. Okay, well, here I go. Your radius is what? 2960, right? Miles. So it's 2960 miles times theta. But you just said you went all the way around the world. That's what? Isn't that 2 pi? That's 2 pi. Do you realize what I just calculated is the arc length? If you took this times this, you just figured out how far you travel around the world. That's the circumference of the world. Earth. Okay? Now, the question becomes, how fast are you going? Well, you got to divide by what? Now, people said this morning, well, how do I know how long it takes? Well, if you went all the way around the world, 24 hours in a day, right? So it's 24 hours. Okay? And there you go. That is how you do it. And so linear speed equals what? Roughly?
774
0.9 miles per hour. And there it is. Now somebody said, well, how did you know to put 2 pi? I said, well, I didn't have to put 2 pi. I could have put anything I wanted. Could I have done this? Could I have said, I'm only going to travel this far? Is it okay if I just travel this far?
Yeah.
How far did I go?
1 r.
Pi over 2. I didn't go half a circle. Half a circle would be pi. Okay, that's a quarter circle. I could have done what? Pi over 2. I could have done pi over 2, but then this would have to be what? That's only 1/4 of the day. That would be 6 hours. See, it really depends on what you put up top. Whatever you put up top better match the time below. Okay? You can't go wrong unless you don't know the time. And you have to adjust the time if you're going to adjust the radius. I would, if I were you, I would think circles. That's what I would.
I feel like I'm going somewhere.
All right, last slide. Here's the deal. There's not much to do here. I just want to prove something to you. Ready? It says, one more formula coming at you, and then just try to understand. I'm trying to help you. We can use the arc length formula, and the arc length formula is right here. Arc length equals radius times theta. To discover an important relationship between linear and angular speeds. Here it goes. Here's your arc length formula right there. See it? They say divide both sides by what letter? T for time. If you divide S by T and then just do theta by T. Don't do the R, just do theta. Watch what happens. S over T is really, right here, it's really what? It's linear speed. So S over T can just be called linear speed. So linear speed equals, leave the R alone, don't touch it. What's theta divided by time? Yeah, but what's omega?
Angular speed.
Angular speed. Oh, there you go. Good. Guys, look, this is all you got to do. If you are ever given two of these three variables, use this formula. If somebody told me the radius and the angular speed, I could get linear speed just by doing what? Multiply. Can I prove it to you? Think of the Earth. What was the radius of the Earth? 2960, right? Miles. What's angular speed? Angular speed was, what'd you say? Theta over time. Thank you. Theta over time. Let's pretend I went all the way around the world. That would be what? 2 pi. How long did it take me to go all the way around the world? 24 hours. Guess what your angular speed is? Reduce that, please. Pi over 12. Guess what? You just found what? Linear speed. If you type that into your calculator, do you know what the answer is?
774.
The same thing you got on the previous slide. You guys, all I'm trying to tell you is this replaces the old formula you did on the previous slide. So, if you want to write yourself a note, this right here, this replaces linear speed equals S over T. You don't have to do this. if you know R and angular speed. If you know those two guys, it's really, really simple. So simple. But some of you are going to make it hard, and you'll go back here and you'll try to work it out. But that is another way to calculate linear speed. I have one more slide. I'm not doing anything. I'm just telling you this. Your assignment will have area of a sector. To me, area of a sector is what piece of the pie do I want to eat? I want to eat this sliver of the pie. Well, what's the area of that sliver? It's right here. Area equals 1/2 theta times r squared. Write this stuff down. You're not going to remember it. Okay, area of a sector is right there. But I do need to tell you this. Theta is measured in what? Again, they're going to trick you. They're going to give it to you in what? Degrees. And you're going to punch it in, and you're going to say, here's my answer. And you're going to be wrong, and you're going to get half credit probably. Maybe not even that much. At least you tried it. I'll give you something. I'm not doing a problem like this. It's very simple. You just have to know the formula, okay? But it's in your assignment twice. Lauren already said this. Did the assignment change? Not really, but I got to tell you, period 3, period 4. They told me if you go by every third problem, you don't end on 118. You end on what? 117. So do 117 instead. Also, I don't like 114. Would you skip it and do 115? Do 115 instead.
So Mr. Payton,
Slight change in the assignment.
so Mr. Payton, let's figure out what the sliver
I'm
before
going to shut this down.
spinning.
Hang on, Harry.